Hi guys, good evening. I am Ilangovan, onlineaxi.com personal for teaching zoology. So we started the last class about the various types of health disorders. How far we are being affected by different types of microorganisms found in this world. And also we talked about the bacterial and viral diseases. Now the third category we have to talk about something about the protozoan diseases. You know that the protozoans are microscopic organisms but eukaryotic organisms but somewhat better and larger in size than that of bacteria or viruses. For example, starting from amoeba to the largest organisms included under this category. So all are eukaryotic organisms having a definite nucleus. That's why we can say eukaryotic unicellular organisms. And some of the protozoan organisms are acting as parasites, that too acting as pathogens causing diseases. Now the most serious disorder what we have developed by a protozoan parasite, malaria, malarial fever. So the malarial fever is now spreading that one because of the insect. It is also considered as that one a tropical disease. So in tropical areas, we have a number of disorders transmitted by vectors like insect because the tropical environment favors the spreading of mosquitoes or any other insect. That is why we have more of the diseases found in tropical areas when compared to that is the temperate regions. So we can say the malaria, filaria, yellow fever, dengue fever, then Japanese encephalitis, all are considered as tropical diseases because they are more prevalent, or we can say most prevalent in tropical areas because the temperature available will be suitable for the multiplication of the vectors, namely the mosquitoes or any other insect. That is why we have a number of disorders more common in tropical areas transmitted with the vectors, particularly insect. So malaria is one such a tropical disease normally transmitted by means of a vector, namely just actually the female Anopheles mosquito. Female Anopheles mosquito. Normally we can say female Anopheles gambiae, the species. But what is a causative organism? The causative organism is nothing but a protozoan parasite, what is called Plasmodium. So it exists more than one form. So we can have 4 different types of species of Plasmodium, normally found in India, causing malarial fever. So the causative organism, a Plasmodium, a parasite. Now this parasite was first known, by means of MLT Dr. Leavenworth. Then extensive study has been made by Ronald Ross and he found that actually these parasites were transmitted with a vector, namely the female Anopheles mosquito. Further he was awarded Nobel Prize. So anyway, the causative organism for malaria is nothing but Plasmodium. It is being transmitted by a vector, namely female Anopheles mosquito. Normally the male mosquitoes do not transmit the disease because they do not have the modified mouthparts for sucking and injecting and sucking the blood. That is why the males never transmit the disease, only the females transmit the disease because of the presence of well specified mouthparts in the case of female when compared to male. Now, what are the organs which are being affected normally in the body, or we can say what are the site of infection? So, one organ and one cell being affected, or we can say 2 systems being affected. One is what is called the spleen, another one the circulatory system or the blood vascular system. That is specifically the RBCs or the red blood corpuscles are affected. So, the 2 important areas where you have the parasite causes damage is nothing but RBC and liver. And these are the 2 places normally the parasite is completing its life cycle, that is RBC as well as liver. We are not going to talk about the life cycle of the parasite. So normally the parasite, you see that when the female Anopheles mosquito bites in the evening and transmits the disease, particularly that is actually sucking the blood. While sucking the blood, it injects the parasite from its saliva. So the mode of injection is nothing but the mode of actually the entry of the parasite is called inoculation. The mode of entry of the parasite is by means of inoculation. There is nothing but injection of the parasite by the female Anopheles mosquito. So the infective form, so we have different stages in the life history of the parasite. So the infective stage of the parasite is called sporozoite. The infective stage of the parasite is called sporozoite. So the method of entry of the parasite is by means of inoculation. That is nothing but the injection of the parasite by the female Anopheles mosquito. The infective stage of the plasmodium is called sporozoite. And that is the one which enters into the body. After circulating sometime, it enters into the liver where it multiplies and releases into the blood. And again from the blood it reaches RBCs where it completes its life cycle and go on. So we have these are all the stages. We are not talking about the life cycle anyway. Now what are the symptoms we have developed? Normally we have chill and then sudden increase in temperature about to 106 degree Fahrenheit. The body temperature rises 106 degree Fahrenheit, and finally once again it subsides. You have the sweating. So the chillness of the body is because of the sweating, and the rise in temperature you have the fever, and also we have the tremor because of the increased fever. So this fever occurs recurrently, either once in 2 days or once in 3 days, or we can say once in 48 hours or once in 72 hours according to the nature of the parasitic species. So the main symptoms are chill and high fever. The fever is normally recurring every 2 to 3 days or once in every 48 hours or once in every 72 hours. So we have different stages: chillness, then sweating, increase in temperature, and not only we have these symptoms, normally the enlargement of the spleen. The spleen, which is considered as a store organ of blood, becomes enlarged because of the increased number of the parasite in the RBCs in that area. So enlargement of the spleen also one of the symptoms we have. And also we have another symptom, anemic condition, because of the destruction of the RBCs. How does it occur? So when the parasite is undergoing different stages of life cycle in the RBC, it feeds on hemoglobin of RBC. It feeds on hemoglobin of RBC. While feeding on hemoglobin, it releases a toxic product as a byproduct, namely hemozoin. This is the byproduct of hemoglobin released when the RBCs are ruptured. The fever is due to the presence of this toxic substance normally found in the plasma. Once it is released from the ruptured RBC because of the effect of the parasite, it is the sole proprietor responsible for causing the fever, namely the malarial fever. And normally the hemozoin granules are released from the RBC once in every 48 hours and once in every 72 hours. Accordingly, whenever this parasite releases or whenever this toxin is released by the parasite from the RBC, the fever occurs recurrently. So anyway, it is normally assisted by the release of hemozoin granules, the toxic byproduct of hemoglobin, while the parasite is feeding on hemoglobin, because the food of the parasite is nothing but hemoglobin only. Then how to prevent the disease? So before entering into that one, we have to go through which are the parts which are affected by the malarial parasite. I mentioned already we have different types of parasites, different species of parasite: Plasmodium malariae, Plasmodium vivax, Plasmodium falciparum. So these are all Plasmodium ovale. These are all the 4 different species of the parasite, and they cause a fever at different stages. For example, excepting Plasmodium malariae, all others, namely Plasmodium ovale, Plasmodium falciparum, Plasmodium vivax, all these 3 cause malarial fever once in every 48 hours. That is why it's called as tertian malaria. If the fever occurs recurrently once in every 48 hours, then it is called tertian malaria. Tertian. So it may be benign tertian and malignant tertian. So benign tertian means doesn't harm. For example, Plasmodium vivax and Plasmodium ovale, they cause tertian malaria. Simply we can say benign tertian and mild tertian. But whereas the Plasmodium falciparum, the most dangerous one, which not only affects the circulatory system but also the brain, and that one causes what is called malignant malaria. Malignant malaria, pernicious malaria, we can say also subtropical malaria, because it is highly fatal. The malaria which is caused by Plasmodium falciparum is highly fatal. So that is why it is called as a malignant malaria, because it causes harm to the body, even leading to the death of the individual. So we have either tertian malaria or what is called cotton malaria. For example, the Plasmodium malariae, the species causes what is called cotton malaria, That means once in every third day or once in every 72 hours we have, sir, once in every just 72 hours we have the disease. Not third day, that is a fourth day. Once in every 72 hours we have the disease. That's why it's called cotton malaria. So according to the nature of the species, we have different types of malaria. We'll be getting more and more information in higher classes. Anyway, we have two different types of malaria. One is tertian, another one what is called actually cotton. Even among the tertian, we have benign tertian and malignant tertian. Benign tertian is harmless, whereas malignant tertian is harmful or fatal to the body. Then cotton malaria just normally occurs once in every 72 hours or once in every fourth day. Now, what are the different parts of the body which are affected by the malarial disease? Now, I mentioned already, for example, the case of cerebral malaria and malignant malaria caused by Plasmodium falciparum. The brain is affected, the person develops headache. Then system. So, if any disease affecting the whole body, then it's called systemic disease. So the whole body is affected because of the fever. So we have fever all over the body. Then muscular. The muscles are also being affected. So tiredness of the muscle, and that is called fatigue, and pain all over the muscles. And that is the symptom related to the muscle. And then also we have in the back pain. These are all some of the symptoms related to. And in the skin, because of the sweating only, we have the chillness. So sudden rise in temperature. All of a sudden the temperature subsides, leading to sweating. That sweating causes the chillness of the body. Then also we have the dry cough without any, just what is called sputum release. And one of the symptoms what I mentioned earlier, the spleen enlargement, what is called splenomegaly. Because spleen is actually setting bed or the storehouse for the blood. So it is the only organ which receives blood from all parts of the body. That is why the parasite reaches there. That is a storehouse of the blood, and the parasite also, that is a storehouse for the parasite. So the spleen enlarges because of the effect of the parasite, one of the symptoms. And also the persons have developed a feeling, a sensation of what is called vomiting, not actual vomiting, but a sensation of vomiting, what is called nausea. And along with, we have in some cases vomiting occurs. So these are some of the symptoms related to the body. The whole body is affected and the different regions affected because of the malarial fever. Then how to prevent this malarial fever? So and before that, actually I mentioned already, one person contributed much towards what is called this malarial fever and also the vector. And it was Ronald Ross actually discovered the presence of the malarial parasite in the stomach of the female Anopheles mosquito. Then only it came to know that actually the parasite has been transmitted through the vector, namely female Anopheles mosquito in 1899. And for that only he was awarded Nobel Prize in the year 1902. As the just actually he exposed that idea just in 20th August. That is why 20th August of every year is celebrated as Malarial Day, because the discovery was made only on 20th August. He found that the malarial parasite found in the stomach of mosquito, and that is why the day now considered as actually the Malarial Day. We are celebrating every year the 20th August as a Malarial Day. Then how to prevent the disease? So normally it is not possible to immunize the body against malaria. We cannot cause the immunization against malaria. So immunization is possible only when the organism is responding to the toxin by producing antibodies. But normally the malarial parasite actually once present in the body, even the release of the hemozoin, the body doesn't respond by producing the antibodies. That means the Plasmodium never stimulates the production of antibodies in the body. That is why immunization against malaria is not possible. It is being possible only actually we can treat the malaria by means of what is called chemotherapy. Chemotherapy means treatment of the disease by means of drugs. So we cannot vaccinate the body against malaria. We cannot give immunization program against malaria. We can treat the malaria only by means of drugs. That method is called chemotherapy method. And now the medicine available is nothing but a original medicine, a natural one, quinine, just extracted from that from the bark of cinchona tree. Bark of cinchona tree, we have received this quinine. So nowadays is also available some synthetic drugs similar to the quinine. for example, polydrip, okay, chloroquine, primaquine. So these are all the synthetic actually quinine drugs, anti-malaria drugs nowadays available to treat malaria. And also want just to control the adult mosquito. You know that when we have some vector programs, vector control program. So, and now we are introducing some larvivorous fishes into the body of water where we have the mosquito larvae are available to kill the larvae. We are introducing some larvivorous fishes. You know the meaning of herbivorous, carnivorous, like that larvivorous. Animal which feeds on larvae one. So one fish by name Gambosia. The fish has been introduced into the what is called actually the places where we have the stagnant water is available, where you have the larva is available. In order to kill the larva, they are introducing what is called the larvivorous fish that can kill that can kill actually the larva by eating them. So it is one of the biological control of malaria. And also we are killing the adult mosquitoes, by chemical method, by spraying DDT, etc. But it is not worthy enough nowadays. That the resistant varieties of mosquitoes have been developed against DDT. So anyway, now the prevention is use of anti-malarial drugs like quinine, synthetic drugs also available, killing the larvae, adult mosquito, vector control, etc. These are all some of the methods normally adapted to prevent the malarial fever. Now another most important disease, most abundant also in tropical regions, what is called amoebiasis or amoebic dysentery. So dysentery is more prevalent, either it is bacillary dysentery or protozoan dysentery or viral dysentery. So the dysentery is more common, particularly in the case of tropical regions. Once again, this is because of the abundance of more insect vectors like houseflies. So the houseflies are responsible for transmitting actually the causative organisms responsible for causing the diarrhea or dysentery, etc. Because it is acting as a vector, we can say mechanical vector. So one question you have to remember that one, why is normally there is tropical diseases more abundant, or this amoeba, cholera, diarrhea more abundant, dysentery abundant in tropical regions? The reason for that one, we have just the mechanical vectors like insects, the houseflies more abundant. They are multiplying more and more. So amoebic dysentery is more common in tropical countries because of the abundance of mechanical vectors like houseflies. Now it is another protozoan parasite caused by Entamoeba histolytica. So it is looking like amoeba, that is the name is given as amoeba. Entamoeba, as it is living in the large intestine, it is called Entamoeba. It causes the lysis of the tissue, hence called histolytica. Histology, tissues, lysis, to dissolve or to destroy. So this parasite is living in the large intestine, looking like amoeba, causing the destruction of what is called the tissue. That is why it is called Entamoeba histolytica. Though the name is given for this organism, there is much difference between the normal amoeba and entamoeba. The normal amoeba is a free living form and the entamoeba is a parasitic form. Even in the case of entamoeba, we have two types. Some forms are smaller, some forms are larger, micro and magna forms. Macro forms and micro forms are micro or magna forms. Normally the magna forms are actually pathogenic. They cause disease, they cause damage to the intestine. So we don't want such one. So anyway, the species of entamoeba responsible for causing amoebic dysentery. Now it is a food and waterborne disease. Unlike malaria, malaria is a vector-borne disease because it is being transmitted with a vector, namely the mosquito. But here it is transmitted through contaminated food and water, hence called food and waterborne disease. Food and waterborne disease. Now which is a site of infection. The parasite enters into the intestine where it survives and causes damage, particularly the large intestine. So the place of infection, the site of infection for the parasite, large intestine. Now the parasite lives there, penetrating through the wall of the intestine, the mucous layer, and also the other layers of mucosa layer. And while just it penetrates through the layers of the intestine, it feeds on the mucus as well as the blood cells or the blood. So that one of the major symptoms of amoebiosis or dysentery, that is amoebic dysentery, is the stool with excess of what is called mucus and blood clots. That is major symptom. That is normally characterizes namely that is amoebic dysentery. Mucus normally found in excess in the stool along with the blood clots. So this is all the ulcer content is released by the parasite while feeding on the mucus and other layers of what is called large intestine. That's a major symptom. Stools with excess mucus and blood clots. Along with you have constipation, abdominal pain and muscular cramps. Abdominal pain and muscular cramps. So normally the parasite never expresses itself immediately. Once the parasite enters into the body, it stays there inside the body for 2 to 3 weeks. Then 2 to 3 days. Afterwards only we are getting the symptom immediately. So that is called the incubation period. Then how to prevent? So as the parasite is entering the body because of the contaminated food and water, we have to follow what is called a personal hygiene and keep your body away from the parasite. And once you have developed the disease, you have to make use of the antibiotics to kill the entamoeba and to arrest the dysentery. So personal hygiene and use of antibiotics are the two major normally preventing measures to prevent amoebiasis or amoebic dysentery. Then I mentioned already how can you differentiate amoeba from entamoeba. So if you are taking amoeba, you know that one it is having pseudopodia. Many pseudopodia are found in the case of amoeba. But in the case of entamoeba, if you are taking the parasite, it contains only one pseudopodia. Only one pseudopodia. See here, this is amoeba having many pseudopodia, but in the case of entamoeba, it contains only one pseudopodium, by which we can identify whether it is amoeba or entamoeba. Now, so as per your syllabus, only 2 disorders are given for protozoan parasites, but we have a number of protozoan diseases, some more Kala-Azar. So the Kala-Azar also called what is called skin leishmaniasis. Leishmaniasis caused by a protozoan parasite, Leishmania. Leishmania. It is also a vector-borne disease transmitted by one insect named the sandfly. The sandfly is the vector for this one, Leishmania. Again, there are 2 different types of species, Leishmania donovani and Leishmania tropica. The Leishmania donovani causes the disease what is called Kala-Azar. Some blisters develop on the surface of the skin. And another species, Leishmania just actually tropica, that causes what is called visceral leishmaniasis. So like that we have Kala-Azar, a disease of protozoan caused by Leishmania, normally transmitted by sandfly phlebotomus. Then African sleeping sickness. So this is another disorder caused by a flagellate protozoan. Once affected, it retains there in the blood and also entering the brain where you have the fluid, what is called cerebrospinal fluid. It stays there and causing infection to the brain and making the person unconscious. That's why it's called as African sleeping sickness, caused by one parasite, what is called trypanosoma. Trypanosoma. So this is a one, Trypanosoma gambians. A parasite, a protozoan parasite, a flagellate parasite. Kala-Azar is also caused by the parasite, a flagellate parasite having a flagellum, just the one used for movement. African sleeping sickness is also caused by a flagellate protozoan, what is called trypanosoma. So it is also transmitted by a vector, what is called tsetse fly, another insect. Tsetse fly. The binomial for tsetse fly, Glossina palpalis. So tsetse fly, the vector for the transmission of the trypanosoma, the vector. So that is the responsible of this trypanosoma to cause the African sleeping sickness. Then giardiasis. This was the first ever known protozoan disease. It was the first ever known protozoan disease caused by a flagellate, the one which causes diarrhea in the case of children, giardiasis. The name of the parasite, Giardia intestinalis. Giardia intestinalis, that's why the disease is called giardiasis. The name of the parasite, Giardia intestinalis, responsible for causing the disease, the giardiasis. It was the first ever known protozoan disease. So that's why it's called, the parasite is called as the old man of the stomach. The old man of the stomach, because it was the one found earlier, the first protozoan disorder caused by Giardia, a flagellate protozoan. So what I mentioned here, the 3 different types of diseases, all caused by flagellate protozoans having flagella. So these are all some of the protozoan diseases caused by the protozoan parasites were transmitted by the vectors. Mostly the parasites are transmitted by the vectors. Then the last one, what we have, the fungal diseases. So we have so far the bacterial disease, the viral disease, the protozoal disease, now the fungal disease, and also we have one more, the macroparasitic disease, what is called the helminthic disease later. Now these are all the microforms. Now the first one, ringworm, the most common disease, you know that one, very often the children are having this disorder. So the most common infectious disease, don't forget, most common infectious disease caused by fungus. So there are three different genera, genera of which fungi are different species of fungi, namely you see that one, Microsporum, Epidermophyton and Trichophyton. Microsporum, Epidermophyton and Trichophyton. These are all three different genera responsible for causing the ringworm. So the ringworm is actually not a worm disease, it's a fungal disease, as we have developed some ring-like structure caused by these parasites on the skin surface. You can have the skin lesions in the form of a ring, and that's why the disease called the ringworm. Not only on the surface of the skin and also on the surface of the skull we have the infections. Now the infection is caused by the fungus, the three different genera, Trichophyton, Epidermophyton and Microsporum. And from where we are getting actually the infection? Either from the soil or from the fomites. So normally the fungus, the microfungus, normally found in the soil. So while we are just playing, the children are playing, they are getting the infection. That is why it's more common in the case of children rather than in the case of adults. So we have from soil, and that is called the direct contact, a direct method. While contacting with the soil where we have the spores of this fungus, then ultimately enters into the body, just from soil or from fomites. I mentioned already what I mean by fomites. The contaminated objects like towels, the glass tumblers or the handkerchiefs or any other materials which contain the parasites used by what is called the infected persons. So these are all called the fomites. So either from soil, that is called the direct contact, or from the fomites, that is indirectly, it enters in the body. Then what are the symptoms? We have developed dry scaly lesions, dry scaly lesions, either on the surface of the skin or on the scalp region or on the nail region. We have developed such things. This is what we have developed. And sometimes you know that one, we are just scraping the skin scalp, and that is being powdered and that is being released as what is called snow-like materials. Then how to maintain? How to prevent this disorder. So maintenance are again the personal hygiene, because it is coming only from the soil. You have to keep yourself away from that contaminated soil. So just actually maintaining personal hygiene and public hygiene, these are the two measures, along with taking the antibiotics to just cure the disease, using what is called the creams also to cure the fungal disease. This one, the ringworm. So some other actually diseases related to what is called the ringworm, or for example athlete's foot. We have aspergillosis, candidiasis, Dobby's itch. Because of using what is called the clothes used by different persons, we are getting the itching sensation. All are fungal infections for you. Now this is the ringworm. You see that one, a ring-shaped structure which is developed on the surface of the skin. This is because of the infection of the fungus, Microsporum or Trichophyton or Epidermophyton. That is why the name is given ringworm. It is not a helminthic disease or a worm disease, but a fungal disease. The appearance of that, what is called the symptom, is looking like a ring-shaped structure on the surface of the skin. Hence the name ringworm. So other fungal diseases, what I mentioned, you see that one, athlete's foot. The one which develops between what is called the fingers or between the toes, particularly the toes. When a person is always wearing the shoes or canvases. So in such cases, actually the athletes are using such things. So that worm is normally causing the development of the fungus between the toes, leading to athlete's foot. And aspergillosis, another fungal disease, candidiasis. It is very common just in the armpits, in the groin region. And Barber's itch, this is because of the use of clothes from some other persons already having infections. That is why it's called as Barber's itch. Using the razors, the one already used for another person having the ringworm or fungal disease, when the same razor has been used, it has been transmitted from the saloon to one person to another person. That's why it's called barbarous age. Now the last one we have what is called the macroparasitic diseases, what we have the helminthic diseases. Helminthology, the study of worms. So now in the animal kingdom we have two different types of worms, you know that one. One is called as a round worm, another one is called as a flat worm. A round worm and another one flat worm. Round worm, another one flat worm. So these all together called as actually the helminthic worms. The study of such worms together called helminthology. Helminthology, the study of worms. Either it is round or flat together. And such diseases or those diseases caused by such worms are together called as helminthic diseases. Okay. Now we have a number of helminthic diseases. Normally it is found in the case of once again children, because the children are always in contact with the soil or any contaminated just particles. So normally the parasites, the helminthic parasites enter your body mainly through what is called fecal oral route. The meaning for that one are just from the soil or contaminated food. So normally the spores or the eggs are released into the soil, and while the child is playing with this contaminated soil, it enters into the fingertips, and then while not washing the hands properly, if the child is not maintaining what is called personal hygiene, so the eggs or what is called the embryo enters into the body through what is called eating process. So that's why it's also called fecal oral route, actually the method of entry. So the roundworms and flatworms are the parasitic worms responsible for causing disease. Now let's take first one, the roundworm. So one such roundworm, the common roundworm, what we have Ascaris lumbricoides. The common roundworm, what is called Ascaris lumbricoides, and that one causes the disease what is called ascariasis. It's a very common disorder in the case of children. You know that one is ascariasis. Ascaris lumbricoides, the one which causes ascariasis. So we have a number of roundworms, for example, hookworm, pinworm, just actually the whipworm, it's a guinea worm. So we have different types of roundworms. For example, hookworm, Ancylostoma duodenale, or just we have, for example, pinworm, just actually Enterobius vermicularis, or just we have what is called guinea worm, Dragongulus medinensis, Trichiurus worm. So like that we have a number of worms just found in the body. So one such worm, that is what is called Ascaris lumbricoides, the one which causes ascariasis. So the portal of entry, or what we have just actually the entry or mode of transmission, contaminated food and water. Mode of transmission, contaminated food and water. And now the parasite enters into the stomach and then finally reaches the intestine and lodged there. So the site of infection is intestine. So when the parasite is found in the intestine, it absorbs all those food materials what we are eating, and also just actually penetrates through the wall of the intestine, causing damage to the RBCs, leading to what is called internal bleeding. While the parasite is normally just making some scrapping of the mucous layer of the intestine, the inner wall, along with the submucous layer, so that we have internal bleeding. And also we have the muscular pain disease because of the damage caused by the parasite to the intestinal wall. The person also develops fever, and also because of the loss of RBC, decrease in RBC content occurs, leading to anemic conditions. So anemia is a condition where you have the decrease in count of RBC. That is called anemia. And when the parasite is more and more in number, it blocks the passage. By bundling together, it blocks the passage of the small intestine. So causes obstruction to the flow of undigested waste, leading to just the internal problems to the body. So these are some of the symptoms found in the case of mostly children. Then how to? So almost diseases which are normally transmitted through contaminated food and water have to be prevented only by maintaining what is called the personal hygiene as well as public hygiene. So we have to keep the things surrounding clean. So that is very important. That is called the public hygiene. You also keep yourself, and that is what is called the personal hygiene. Very important for such disorders. Now another roundworm disease, the most common one, you might have noticed some persons have huge legs. The legs, extremities of the limbs be enlarged, looking like an elephant's leg. And such a disease is called elephantiasis or filariasis. elephantiasis or filariasis, a disease caused by another roundworm, what is called a filarial worm. It's binomial Wuchereria bankrupti. Wuchereria bankrupti. So this disease also called as bankrupt disease. That is elephantiasis, filariasis or bankrupt disease. So two different people actually discovered this parasite, Wucherer and bankrupt, hence the name for the worm Wuchereria bankrupti. And normally this worm is called filarial worm, unlike other worms. So the worms, roundworms may be or possibly present in the intestinal tract. But this is the worm found in the lymphatic system. This is the worm found in the lymphatic system. See, in the body we have two different types of fluid. One is called as the blood, another one the lymph. The blood is flowing through the blood vessels, whereas the lymph is flowing through the lymphatic vessels. Now this parasite is surviving and leading its life only in the lymphatic system. And it is coming actually up to the bloodstream only during the night time between 10 p.m. to 4 a.m. So the parasite retreats in the morning, hides in the morning up to 10 o'clock in the night in the lymphatic system and enters to the circulatory system only after 10 o'clock in the night, and they stay there in the circulatory system up to 4 a.m. till in the morning, that is early dawn. So the meaning for that one, the animal produces the egg. From the eggs are hatched larvae. So they are called as a juvenile worm. The juvenile worm, the young worm. So the young worm of this parasite, the worm, are called what is called microphyllaria. The young worms, microphyllaria. The larva or juvenile worm of the filarial worm are called microphyllaria. The disease is also called filarial fever or simply filaria, filariasis. For the young worms, the juvenile worm also called microphyllaria. So the microphyllaria normally retreat in the lymphatic system in the daytime and entering with the bloodstream only after 10 o'clock in the night and stay there in the blood after 4 a.m. So that is why for testing this filaria, blood samples to be taken only between just 10 p.m. to 4 a.m. because it is not possible to extract the lymph from the body. It is possible to extract the blood only. That's why you have to take the blood sample only after 10 p.m. in the night before 4 a.m. to find out whether the person has malarial parasite in his body or in her body. So that is the meaning. That means, so it comes up only during night. So animals, you know that one just coming out or doing their activity during night time are called nocturnal animals. As the animal normally hiding daytime and coming out during night, the phenomenon they exhibit is called nocturnal periodicity. Nocturnal periodicity. Nocturnal periodicity. That means the animal is retreating or normally just actually hiding the lymphatic system in the morning or till daytime and coming to the blood only during the night time. That phenomenon is called nocturnal periodicity. So that is about the microphyllaria, the larval form. And how is it normally transmitted? Once again, just like malaria, it is transmitted by the female mosquito, but another species of mosquito of another genus we can see, for example, Culex pipiens. So malaria is transmitted by female Anopheles mosquito, but here it is transmitted by female Culex pipiens, another mosquito. Then what are the site of infections? The legs are affected, the foot are affected, there is scrotum affected in the case of male and breast affected in the case of female. These are all the site of infections. Now what are the symptoms we have developed as a result of this filarial fever? You see that one. So enlargement or swelling of the extremities of the limbs. You see that one, enlargement of the limbs. Not only that one, the extremities also. Enlargement or swelling of the extremities of the limbs. That's the main symptom. This is because of the blockage of the lymph by the parasite. Due to the blockage in the vessels, the lymph accumulates in the limbs, being retained there giving the appearance of elephant's leg. That's why it's called elephantiasis. That's why it's called elephantiasis. So enlargement, a swelling of the extremities of the limbs, and also swelling of the scrotum where the testes are large in the case of males. Swelling. So swelling of the scrotum and the swelling of mammary glands in the case of female. So not only these symptoms occur, along with the swelling we have the fever, what is called the filarial fever in the case of such people. And also we have the what is called the inflammation of the lymphatic vessels, lymphatitis, we can say lymphangitis. So the lymphoedema, the accumulation of fluid that leads to elephantiasis, that condition is called lymphoedema. The enlargement, or just what we can say, just the inflammation of the lymphatic vessels is called lymphangitis. And again we have some lymph glands are found in the body, what is called the lymph nodes, the thymus, etc. They get enlarged. And such enlargement or inflammation of the lymphatic glands called together lymphadenitis. So we have some technical words related to either lymphoedema or lymphangitis or lymphadenitis. These are all some of the symptoms related to what is called the filariasis or elephantiasis. But notably you can see the enlargement, visible symptom is nothing but the enlargement of the limbs, particularly just the hind limbs, along with the enlargement of the scrotum and swelling of the mammary glands. Then how to protect? As it is being produced or transmitted to the vector mosquito, we have to just actually protect us from the adult mosquitoes by killing them. And also the larva. So we have to prevent the stagnation of water and killing the larva, destruction of larva by spraying what is called DDT or any other what is called, that is the pesticides. And use of anti-filarial drugs. One drug is available, what is called hedrazone drug, and that is used for killing what is called the larval forms, the microfilaria. So microfilaria, nothing but the larva. See that one, filaria, the fever, microfilaria, nothing but the larva. So don't confuse with these two. Filaria, the symptom, the fever caused by the parasite. Microfilaria, nothing but the larva of the parasite, namely the filarial worm. Then, so in addition to these two, just these two are caused by the roundworm diseases. For example, you have the what is called the ascariasis, another one the filariasis, both are caused by roundworm. And some disease caused by flatworms. For example, teniasis and bilharziasis or bilharzia. Teniasis and bilharziasis are simply bilharzia. Now, teniasis is a disease caused by the flatworm, not the roundworm. The first two diseases, ascariasis and filariasis, caused by roundworm but a helminthic worm. And here teniasis caused by a flatworm. Flatworm, what is called teniasolium. Teniasolium, a flatworm. So it is also living in our intestine, causing damage to our intestine, also causing the disease what is called teniasis. And another one, that is bilharzia. Now it is caused by one flatworm, normally found, just normally called as a blood fluke, found in the pelvic vein. One blood vessel found in the abdominal region, what is called a pelvic vein, where it is found in the pelvic vein, caused by actually the parasite living in the pelvic vein. The name of the parasite is called cystosomia. Cystosoma hematobium. Cystosoma hematobium. That is the name of the parasite, which lives in the pelvic vein. The vena, just normally found in the pelvic region, in the abdominal region. Below we have the pelvic region, where you have one vein where this parasite is found abundant. And once a person is infected with this cystosoma, then the person develops bilharzia. The disease also called cystosomiasis. Another name for that one is only bilharzia. And here what will happen? The urine is eliminated along with the blood. So the main symptom is hematuria. The main symptom is hematuria or hematuria. So nothing but blood contained urine or urine with blood. You can say urine with blood. So urine is actually eliminated along with blood. That is one of the symptoms of bilharzia caused by the blood flow. So this is caused by blood flow and this is caused by the tapeworm. The common name for this tinea solium is a tapeworm. So teniasis is caused by tapeworm and bilharzia is caused by the blood flow. The symptom blood in urine, that symptom is called hematuria. So these are all some of the disorders related to the different kinds of parasites. Either microscopic parasites or what is called macroscopic pathogens like the worms. So all these things together, we have the diseases caused by bacteria, the viruses, the fungus, the protozoans, and also we have the helminths. Now, how we are protected from these diseases, natural or artificial? And for that we have to know another just actually topic, what is called immunity. Immunity. So the word immunity is normally coming from the Greek word immunis. Latin word immunis, and the meaning for that one, exempt or freedom. That is a person free from the disease. A person free from the disease has a resistant power. That resistant power is called what is known as immunity. So immunology, the study of immune system is called immunology. And as normally Louis Pasteur normally developed this concept, he is called father of immunology, Louis Pasteur, because he has developed some type of vaccines against the microbes. So immunology is a branch of science that is concerned with the immune system or the study of immune system. Concerned with the immune system or the study of immune system, or simply we can say study of immunity or immune system is called immunology. And what do you mean by immunity? We have the simple definition. Simply we can say a person has a resistance power against a disease. That is called immunity. So the word immunity refers to the resistance normally developed by the host organism. The one who is acquiring the disease is called as a host organism. The one who is providing the space for accommodation for any parasite is called as a host organism. So it is the resistance power developed by the host organism against injury. That injury is normally caused by the microorganisms and their products. So microorganisms are causing damage to our body. For example, tetanus bacteria. It releases toxin. That toxin affects our muscles. So both the bacterium as well as its product, namely the toxic product, causes damage to the body. If you have the resistant power against the products as well as the microorganisms, that power is called immunity. So the word immunity refers to the resistance that is developed by the host organisms against injury. That injury is caused by the microorganisms or its products. That is called what is known as immunity. How can you develop this immunity? So the immunity is nothing but the functions of the immune system. A person has developed resistance power against a disease or against what is called the toxic product released by the microorganism because of the immune system. So, what is the important property of an immune system? So, the immune system has the ability to differentiate or to distinguish what is called a self. The word self refers to the own body, where you have the immune system is formed. So, the host body is called as a self. And the one which enters the body in the form of microorganisms or toxins is called as a non-self. So which is normally called as foreign. Why we are using as foreign body? Any substance which will not be accepted by your body is called as a foreign substance. We can accept some, so we are eating food that is being accepted. But if there is any toxic product present in the food and that toxic product is not accepted by your body, then it is called as a foreign. So any toxic product which will not be accepted in the form of toxic product, or we can say in the form of microorganism, anything which will not be accepted by your body or considered as a foreign. So one of the important properties of the what is called the immune system is its ability to distinguish what is called the self and non-self. So that what it can just eliminate what is called the non-self invaded in the body in the form of microorganism or in the form of any toxic products. That's the most important property. Otherwise, what will happen? The immune system may affect our own body. Some cases it is happening, leading to what is called autoimmune disease. If our immune system, the one which gives resistant power against the disease, Instead of attacking the foreign substance, attacking our own body cells and substances, then the disease developed is called what is called autoimmune disease. Autoimmune disease. So anyway, the immune system is normally capable of recognizing self and non-self. Self is our body, where it is normally placed, and non-self any foreign body. Okay. I mentioned already Louis Pasteur is called as father of immunology because he has developed vaccines against, for example, rabies. Rabies vaccine he developed, cholera vaccine he developed, so anthrax vaccine he developed. That's why he's called as father of immunology. And we want to know thoroughly about immunology, we have to know what do you mean by antigen and antibody. So these are the two major components responsible for developing immune power or resistant power in the body. So what do you mean by antigens? I mentioned already. An antigen, any foreign substance. It may be in the form of microorganisms. The one which causes disease, then it is called infectious. Not all the microorganisms are causing disease. And those which cause diseases are called infectious organisms. So the word antigen refers to either the infectious organisms or the toxins or the products released by them. The word toxin refers to a poison or any foreign protein. I mentioned already the word foreign. So most of the antigens are in the form of proteins. For example, if taking the venom of a cobra, it is a protein. Or if you are taking blood from one person to another, if it is not accepted, so if you are donating blood from B to A, then it is considered as what is called a foreign protein. So we can just actually transfuse blood between the two persons having the same blood group. Generally we can say. This is general statement, not specific. And if you are giving just a B blood to A person, then the B blood is considered as what is called a foreign protein. So any antigen substance is nothing but in the form of microorganisms or infectious organisms, or in the form of toxins released by them, or any foreign protein that enters into our body and causing damage to the body. They are called as antigens. So that's why I represent here the infectious organisms that invade the body or the toxic products just normally produced by them, and any foreign proteins entering the body are called simply antigens. So antigens, it may be microorganisms or the toxic product released by them or simply just any foreign proteins. Now to counteract, to oppose these antigens, there are certain substances released by the immune system, and such protective substances are called antibodies. So these are the two components we have to know in order to just actually explain the mechanism of immune system. So antigens from external source enter in the body. Once the antigens are entering into the body, they stimulate the body to produce. They stimulate the body means they stimulate the immune system to produce certain proteins. And these proteins are normally protecting us against the invader, either in the form of microorganism or in the form of antigen or in the form of even the toxins. So that is why we can say the definition for antibodies. These are protective proteinaceous substances. All are made up of proteins one. If you are taking antigens, it may be protein or some others. But antibodies are always protective proteinaceous substances. Protective proteinaceous substances because they are giving protection to us. Chemically, these protective proteinaceous substances are called actually immunoglobulins. So antibody is a common name. Chemical name for this antibody, immunoglobulin. As they are protecting us from various microorganisms and their products or any foreign substance, they are called as omniproteins. Omniproteins. So simply we can say the antibodies are protective proteinaceous substance. The nickname for them omniproteins. The chemical name for them immunoglobulins. So normally they are produced by certain cells, one type of WBC. So we have the WBCs different types altogether, 5 types. One type is called lymphocyte. Even under the lymphocyte we have different types. One type of lymphocyte is called B lymphocytes. That is the one which produces antibodies or immunoglobulins in response to antigens. What for? To detoxify them, to just neutralize that effect. either making the bacteria or any microorganisms stick together, or making such actually organisms to be easily swallowed by the cells found in the body WBCs, or they are neutralizing the toxins released by the bacteria or anything else. So anyway, there are many proteins. That's why I said actually protective protein is substance, chemically called as immunoglobulins, and the cells responsible for the production of such antibodies are called B lymphocytes, a type of lymphocyte, and they are normally produced only in response to the entry of antigen. What for they produce? To nullify or to detoxify the effect of antigens, to nullify or to cancel or to detoxify the effect of antigens. So that is what we have, the antigen and antibody. These are the two important components what we have to know for the thorough study of the immune system. Now we have different types of immunity. Some resistant power already we have right from the birth. Some resistant power being developed only after the birth or acquired accordingly. So just I am saying something already present in the body right from birth, naturally. That is, they are non-specific actually. They can just fight anybody that enters in the body indiscriminately. Anyone can enter in the body being affected, being normally attacked by this immunity. So, according to their presence, according to the nature of the immunity, whether it is present right from birth or it is being acquired or received after birth, we can classify the immunity into two types. One, natural or innate, native immunity. Another one, acquired immunity, also called as specific immunity. Now this natural or innate or native non-specific immunity, it is also called non-specific. So what is the meaning for non-specific and specific? So if anybody enters the body, they are simply attacked by this natural immunity. Whether it is a bacterium or virus, there is no what is called specificity. They are attacking anybody that entered the body. That is why it's called non-specific. But the one which is acquired after birth by our body is called as specific immunity, because it can normally recognize only a particular pathogen and eliminates the pathogen selectively. So there is selective elimination of the pathogens. For example, suppose you have an immunity power developed against a smallpox. The immune system normally attacks a smallpox virus if it enters into the body and not the bacteria and the one which causes tuberculosis. So, for example, a person recovers from smallpox, he will not be attacked once again by the smallpox because he developed immune power in his body against smallpox. So during the second attack, when the smallpox virus enters into the body, it is being attacked by what is called the acquired immunity more effectively than the previous one, because you already developed the immune power in the body. So this is what is called specificity. It can recognize a specific microorganism. The same immune system, the one which attacks the virus, the smallpox virus, will not attack tuberculosis bacteria once a tuberculosis bacterium enters the body. The tuberculosis bacterium stimulates the immune system to produce antibodies against it, not against what is called smallpox virus. That's why I'm using the word specific. It can recognize and selectively eliminating the microorganisms. So the immune system, that is the immune power that is developed against smallpox, will not attack what is called tuberculosis bacteria. Similarly, the immune power that is developed against tuberculosis will not attack smallpox virus. This is what is called specific. But here, in the case of natural immunity, they can attack anybody. Whether it is a bacterium or it is a virus or it is a fungus or anything else, they can attack what is called indiscriminately. So without just specificity. So that is why the first immunity, the one which is present right from birth, is called the natural immunity. As it is found right from birth, it is called innate immunity. It is also called as a native immunity. As it is not specific, it is called non-specific. The one which is acquired after birth, because of, for example, recovery from the disease or because of, for example, immunization program, then it is called acquired disease, acquired immunity. And it's also called specific immunity or adaptive immunity because it provides adaptation against a particular disease. It is specific because it can recognize and selectively eliminate microorganisms. Once immunity power developed against smallpox, the immune system attacks only the smallpox virus and not the tuberculosis bacterium. Similarly, once the immune power developed against what is called tuberculosis, that immune system will not attack the smallpox virus, and this is what is called specificity. It can recognize and selectively eliminating the microorganisms. So that is about the broad classification. The one which is present right from birth, another one which is normally acquired after birth. And we have to study furthermore about the specific immunity, whether it is active or just passive. So some cases, it is of longer duration. It is present in the body till you are dead, active. In some cases, it is present only for short duration, that is called passive. So we have active and passive. So in the case of active immunity, normally we will go through later in detail. So we have developed certain antibodies against the microorganisms. It is being present in the body till you are dead and protect your body against that microorganism. So it is of longer in duration. And if you are taking passive, so antibodies normally develop not in our body, it is being formed in some other organisms and that is being transferred to our body. Such antibody which will not be produced by us but transferred to our body for protecting us from various diseases is not long lasting. It is resisting the body only for a short period, that is called passive. So we will go through just about this immunity, the types once again, just the broad classification in the next class. Because of longer time, I am concluding my lecture. So thank you for your listening to my lecture. So you may ask any questions or pose questions with answer.